Now, probability distribution, a statistical function that describes the likelihood of variable taking each value that it can possibly take. Okay, probability is nothing but a chance, right? What is the probability that today some IPL is going, match is going on? Anybody knows between what teams it is going on? In the IPL, we have this cricket called Indian Premier League, and it is going between two, I think RCB versus, is it Lucknow? Somebody can help me if you're in. Oh, Gujarat Titans, is it? Okay, from Gujarat. Okay. So what is the probability that RCB will win? What is the probability that RCB will win? 76%. Okay, now you had an understanding, fair understanding of what probability is like. Somebody is saying 0. Okay, fine. I'm not getting into this now. Okay, thank you very much for your active participation. All I want to help you understand is the probability distribution. There is something called as continuous probability distribution and discrete probability distribution. Okay, so CPD and DPD. Okay, all of you type CPD and DPD, continuous probability distribution and discrete probability distribution. Okay, under continuous probability distribution, there is something called as normal distribution and something called as uniform distribution. Okay, and under discrete probability distribution, there is binomial distribution and Poisson distribution. Okay, if this is clear, type SC, super clear in the chat box. Okay, good. Okay, let me go to the next. I'm going to go a little faster here because many people are scared of probabilities. Okay, I want to make this probability a little easier. Okay, when you toss a coin, what is the probability of getting a head if it is a fair coin? Fair coin means it's not a fake coin, okay, where both are heads or both are tails. Okay, 50%. That's what it said. A head is called as an outcome, which is 0.5, and a tail is 50-50. Absolutely right. Okay, so the explanation I will not read, but what I want to understand is likelihood that certain event or an outcome will occur given a set of data or specific action. So I want you to write two words. One is event and outcome. Okay, please write in your notebooks event and outcome. EO. Okay, EO, event and outcome. If you flip a coin, the probability of head is 50%. So event and outcome is what we are talking about. Okay, outcome is a result. Okay, if you flip a coin once or you randomly select a single item from the sample, and the event is a specific outcome. Okay, so we have something called as a trial, we have an outcome, we have an event. Okay, so these are the things that you need to know. All right, now, so the coin coming up heads is an event. Okay, just for you to understand. Suppose a person is, if I say that this guy is 5 feet tall, is an event when you're talking about a population sample where we are talking about the height of different people in the class. Okay. Now we are going to give an example of a die. How many faces does a dice have? DICE. Okay. How many faces does it have? Coin has got 2 sides, but die has 6 sides. Okay. Good. Okay. Fine. So that basic understanding is important. It's a cube, right? So how many of you have rolled dice before? How many of you have rolled dice before? You have rolled dice, right? Okay, fine. Fantastic. You know, dice find in a board game, right? In the board game you find, or La Vegas, you find that. Well, assume that we suspect a single die is fixed, okay, meaning that it has been altered in some form or a fashion to make a certain number appear more often than rightfully should. Okay, How many of you seen those fake? What is that game called? Some sort of casino games. How many of you seen that fake dice? Type me in the chat box. Like you find that the dice has got 1 to 6 numbers, but some the die is fixed that it doesn't have all the numbers. Okay, okay. Some at least a few people have seen. Okay, fine, no problem. Okay, now consider the example on how we would go about determining, in fact, the die was loaded, okay, or faked or whatever it is, okay. If you threw a die 5 times and got 5 times all the ones, what would you conclude? How sure can be the probability of getting just single one? Okay, now, is it possible that I roll the die 5 times and every time I get one? Is it possible? Type yes or no. We should say the probability is very, very, very less. Okay. Now, what is the probability that you will get a 1 when it is rolled once? What is the probability that you will get a 1 when it rolled once? Not 50-50, that is for coin. 1/6 is the right answer. 1/6 is a right answer. Okay. Excellent. Because 1 out of 6, there are 6 faces it has got, and 1 out of 6. Okay. We are talking about the dice and not. Okay. Now, what is the probability of getting 5 ones together? What is the probability of getting 5 ones? Anybody can attempt this. I'll just give you 15 seconds. What is the probability of getting 5 ones? Okay, somebody has got a phenomenal answer there. 1 divided by 7776. Okay, and I wanted to congratulate Ahmed. Okay, Mr. Mohammad Imtiaz Ahmed. All of you give thumbs up to Mohammad Imtiaz Ahmed, because 1/6 into 1/6 into 1/6 into 1/6 into 1/6 5 times. And if you do that, 1 divided by 6 to the power of 5, it's that number. Fantastic. Okay, very good. Not 1/6 into 5. Okay, 1/6 to the power of 5. Okay, okay. So with a standard die, we would expect one phase to be 1/6 or 16.67% of time. Okay. Now let us understand. If you threw the die 5 times and got 5 ones, what would you conclude? How sure you can be? And this is what it is. So the chance that it happens once is 1/6, which is 0.1667. That into 5 times. Okay, which is 1/6 into 1/6 into 1/6 into 1/6. So 1.3 times out of 1,000 that we can get one. Not even 1,000, right? Yeah, 1.3 times out of 1,000 times. Okay. So therefore, we would say that we are willing to take 0.1% of the chance of being wrong about our hypothesis that I was loaded. Okay, if this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super clear. This sort of understanding, some basic understanding of the probability. Why are we using this probability? What has it got to Six Sigma? I'll tell you, normal distribution has got everything to do with probability. Okay, that's why it's called probability distributions, normal probability distribution. Okay. Okay, so far, if you found it interesting, useful, valuable, fantastic, awesome, put it in the chat box. I want to draw inspiration from your comments and go ahead further. Super, super clear, fantastic, awesome, put it in your chat box. If you flip the coins like this, you would get 50% chance of getting a head and a tail. Again, if you flip it, again, you will get another 50% chance. Again, the outcomes can be 2 times if you flip it. It can be head head, it can be head tails, okay, it can be tails head and tail tails, and hence the probability of getting head head is 0.5 into 0.5. The probability of heading head tails is 0.5 into 0.5. Tail heads is 0.5 into 0.5, and tail tail is 0.5 into 0.5. Okay, so if you see here, This is called as a multiplication in probability. If you do it 2 times, the probability is a multiplication of the 2 events that is happening. Okay. So if this is clear, the sum of probability is always equal to 1. If this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. And some people might find it little overwhelming, people who are not mathematically inclined or intelligent, because every person has different forms of intelligence. There is 8 forms of intelligence: musical intelligence, artistic intelligence, linguistic intelligence, mathematical intelligence, interpersonal intelligence, intrapersonal intelligence, kinesthetic intelligence. There are different forms of intelligence. If you are not, if you're getting little scared of this mathematics, probably we are not mathematically inclined. Okay, don't worry about it. If you're passionate about learning this, please watch my videos and stick on. Okay, be patient and you will eventually understand. How many of you are with me so far? Type WU with you in the chat box. Okay, and let me go into the probability distributions. All right, thank you very much, each and every one of you. And those who have not registered for the upcoming webinar, please register for the upcoming webinar if you need certification. Okay, people who need certification has to register in the special upcoming webinar. Okay. Right. So basic probability can be calculated by the following. We have already said the number of events defined as an outcome, okay, divided by the total event. Okay. Suppose if you toss it once, it's 1 event, and the total number of events is out of 6 that is possible, 1 by 6. In case of coin, there are 2 possible events, okay, that occur when you flip it. Okay, 2 possible events when you flip it. Only one of those events is coming up heads. Okay, so that is 1 by 2. In the case of rolling die, it is, you can either roll 6 possible events or outcomes when you roll a die, which is 1, 2, 3, 4, 5, 6. The probability of rolling a 5 is 1 out of 6, which is 0.7. Okay, probability of rolling either 4 or a 5. Okay, it is 2 by 6. Okay, 2 by 6, which is adding P of A plus P of B. Okay, we'll talk about it later. This is, I'll talk about conditional mutually exclusive events and all that in the coming slides. But then this is an addition, either a 5 or a 6. Okay, are you ready for the Q&A? Type ready in the chat box if you're ready for Q&A. All right, superb. The question. So what is the probability of rolling 5 on a fair-sided die? Okay, you know the answer already, right? You can type the answer in the chat box if you know it already. Yeah, we know it already. So, okay, all of you have given the answer. The correct answer is 1 by 6. We have deliberated enough on this. Okay. Next, the question is, if a coin is flipped once, what is the probability of getting heads? This also we have discussed. So it's a very easy answer. 1 by 2, right? 0.5. So very simple answer, no brainer. Okay. Okay, let's go into this probability distribution. Now, you can see that things can be distributed like this. Okay. Well, probability measurements can be expressed as percentage. They are calculated and are usually communicated in statistics as decimal points. Since probabilities are presented as fractions, okay, the lowest probability. So probability is between 0 to 1. All of you type 0 to 1 in the chat box. 0 means there's no chance it will occur. 1 means there's 100% chance that it will occur. Okay, for example, what is the probability that I live, we will all live for 200 years? What is the probability? Okay, so there's no chance. Okay, zero means there is no chance, right? No chance. Okay. Okay. I remember the quote. The height of hope is we keep an alarm in the morning and hoping to get up, wake up. Right? What is the probability that we will wake up the next morning? This is just a lighter question. Huh? All of you don't panic and take it seriously. What is the probability that you wake up tomorrow morning? 99%. Okay. 99.99% or 99.99999%. Almost certain that most of you are certain that you will wake up in the morning, right? Leaving a remote chance that something might happen to us. Okay. Not 50%, please. Okay. All right. Okay, we have explained about zero. Let's ask a question also, the very simple. What does the probability 1 mean? Okay, this is also a question. Now that you had seen this, you can answer this question. What does probability 1 means? Okay, the event is impossible, the event is certain, the event is unlikely, the event is unpredictable. Okay, it's B is right answer. It's certain, right? Okay, great. Now I'll talk about probability, basic probability practice, right? So those of you who are looking for certification, kindly register in the link of the upcoming session that I posted in the chat box, okay? If you're interested in green belt certification, yellow belt certification, you can register for the upcoming webinar. Okay, so 20 marbles are placed in the bag. All the marbles same size but different colors. What are the colors? Red, black, blue, green. Okay, these are the colors. 3 red, 5 black, 8 blue, and 4 green. Okay. Now, what is the probability that a green marble would be pulled from the bag? Okay. So, what's the probability that a blue or a black marble will be pulled from the bag? Blue or the black marble. Okay. And what is the probability that an yellow marble would be pulled from the bag? Now, you should notice that a green is 4 marbles here and 4 out of 20. And blue or black. Okay, blue or black means black is 5. Okay, blue is 8. 8 plus 5 is 13 out of 20. Okay, that is why summation happens in probability. Okay, and yellow marble is, there is no yellow marble here, so it is 0. Okay, if this is clear, on a scale of 1 to 10, please give me a 9 or 10. It's very simple and straightforward. Okay. All right, fantastic. This is an impossible task because yellow marbles are not there in the back. Okay. Question is the same. Okay. I've given the same numbers here, but then you will not have, when you write the actual examination, you will not have the slide and then this coming up. Okay. A bag contains 3 red, 5 black, 8 blues, and 4 green marbles. What is the probability of a green marble coming inside? Let's see your answers in the chat box. Right. So it's 0.2, right? All right. Now, similarly, what is the probability of getting the number 1 5 times in a row in rolling a fair 6-sided die? Okay, 5 times in a row. What is the probability of getting? Somebody has already answered this. Okay, 5 times in a row. 5 times in a row? So the correct answer is this, and the explanation is 1 by 6 to the power of 5. Okay. I want you to understand this is the probability in a row is multiplication. Okay. Okay. Thank you very much. So probability distributions. Now, how do you apply these basic probability concepts to Six Sigma analysis? You're not dealing with marbles. You're not dealing with bags. Okay. But ideas of probability is similar. Okay. For example, you produce a defect in a product. How many of you produce defects in a product? How many of you can relate to this? Type ICR in the chat box. And you can have 1 defect, 2 defects, 3 defects, 5 defects, 10 defects in a piece of metal, and these are called defectives. What is the probability of receiving a product, okay, as defective pieces? 2 out of 100, which is 0.02. Okay, if you understood this, type US understood in the chat box. This is also a probability. However, it is rare that the team or business unit will review all the 100 products. So they would like to know what is the probability of a defect that is coming out in every hour. Okay. Awesome. So such information of probability is very, very useful. In fact, if you see in the histogram on the right side, there is a red color mark that I have given. Is how many of you can see that? Type ICS, I can see in the chat box. There is a small red color that I put with the arrow. Okay, so those are, which is going out of the specification limit of the customers, those are the defects. Okay, so what is the probability that a defective will be produced or defects will be produced? And the objective of Six Sigma is 3.4 defects per million opportunities. Okay, so we are talking about probabilities there. All right. So if this is interesting, useful, fantastic, awesome, just give it, because no one in Six Sigma explains probability distribution to the extent that I have explained it today, to eventually transition you from rolling of a coin, rolling of a die, to a distribution, to a normal distribution, which is used in Six Sigma. Okay, I hope you understand the value of what I'm teaching today, right? So applying the basic concept is, instead Six Sigma experts randomly sample a population of all the outposts. Samples are taken. Okay, samples are taken from population, and we describe the sample. Okay? We describe the sample, mean, median, mode, okay, and stuff like that. Okay, thank you very much. For those who find it difficult to comprehend or missed something, I will share this video. You can watch this video again. Okay, and descriptive statistics, because go through my earlier videos where I explained about descriptive statistics. Okay, and then when we take the samples, it is called inferential statistics. We infer the population from the samples that is taken, and so we use probability distributions to really infer the population. Okay, histograms. So before we talk about normal distribution, we have to talk about histograms. Okay. Probability distribution, it's important to understand histograms and histogram. How many of you know histograms? Type KNOW in the chat box if you know histograms. It's a type of bar chart representing, it's also called frequency distribution. It's also called FT, frequency distribution. Okay, if you don't know, it's very simple. You can watch YouTube videos also, but you just plot the data on the frequency that they occur. And there are bars like this, it's called histogram. It's a type of a bar chart. Okay, and I have taken histogram in depth in the earlier sessions. Okay, I've also explained about how to construct a histogram. So it is, The data should be a variable data. Okay, like time, temperature. I've also explained to you about what is variable data, what is discrete data, the earlier session. So there is a person called Carl Pearson. Okay, it's also called Pearson distribution. It's also called Pearson distribution, who introduced this histogram. Okay, and histograms are used to show the output of the process that matches the customer requirement. Okay, now also we can take decision based on the data patterns. Now I'm going to show you various patterns in the histogram. From the pattern you see whether the data is normal, or don't call it abnormal, call non-normal. Okay, normal versus non-normal. In statistics we use non-normal and not abnormal. Okay, and we see whether the process is capable or not of meeting the customer requirement. And histogram is the best frequency tool, and it's a pictorial representation, and we use what is called as bin intervals, cell intervals, and all that in the histograms. Okay, and it is used for continuous data. Okay, now a question and answer about histograms is, where is histogram used for? Predicting future data, representing frequency distribution, identifying the outliers. Let us quickly check your knowledge on this. Okay, representing frequency distribution is the right answer here. Okay, fantastic. And those of you who are wanting Lean Six Sigma Green Belt certificate, Yellow Belt certification, please don't forget to attend my upcoming webinar where I'll talk about how to get certification. Okay, and so you've seen a distribution like this. What do you see? One, you see that it's a bell-shaped curve, and the other you see that it is peaked towards the end. Towards the end there is a lot of data, and center there is data. Okay, so this is called normal, this is called bimodal. All of you type BM in the chat box. Bimodal. What is bimodal? Bimodal means, like, if you see, the center is the average and normal distribution. Okay, the center is average. So always it need not be like this. Okay, the histogram shows the data range from lowest data set to highest data. There's a range, right? It shows all the details in the histogram. Now, depending upon the shape of histogram, you can start doing the analysis and interpretation of the data. For example, if you see that in this data, there is in the right side, you see that the data is more towards left and right. It is an indicative that some two samples are mixed, two shift, two operators, two suppliers data is mixed and stuff like that. It's called as bimodal distribution. But if it is like a bell-shaped curve, this is a normal distribution. So the shape of the histogram is very, very important to interpret. Okay. Now I'll show you different shapes of histograms. Okay. And we have already seen this. I'm not reading all this. I've already explained this. One is normal distribution. The other is a bimodal distribution. And I've already explained that the bimodal can be the result of two people, two operators data, or two shift data, or 2 months data, or 2 suppliers data, 2 customers data, etc., etc. Okay, so these are the explanation. Now, what does a bimodal indicate? Again, this is a very, very simple answer. Okay, what is the answer here? Okay, 2 data are mixed. So when I explain and then when I give you the question, it is pretty simple, right? Okay, what I want to quickly take you through this. I'll spend another 2 minutes, couple of minutes in this. Okay, in another few minutes we'll complete this. In a Six Sigma setting, I'll take another 5 more minutes. Okay, why are samples used instead of analyzing the entire population? Any answers you can type in the chat box. Why are samples used instead of entire this? Okay, the choice A is, okay, it is faster and cost effective. Entire population is biased, samples give inaccurate results, population do not follow. Okay, A is the correct answer. It's faster and cost effective. Good. I like the active participation today. And in the histograms, you can also have several shapes that I said. I'm going to show you many shapes. Okay. And also, depending upon the shape, you can find out, you can draw some inferences. Okay. Whether the shape comes from the actual process variation or from the measurement variation. I'll in the next graph. Okay, this presentation I'll give it to you. I hate reading all the words here, but these words are important for you to understand. Okay, but here if you see, these are the two. This is called as a random distribution. Okay, there is no pattern here. This is called the skewed distribution because there is more data on the left side and less data on the right side. And so a skewed distribution, you can see that it's clustered on one end of the graph. Okay, so skewed histograms are common with certain types of data, particularly in the fall off. Okay, webinar fall off after a particular time, it is skewed. Okay, when you make offer of anything towards the end of the webinar, people will drop off. That's all skewed data, right? Call center also and stuff like that. Okay, time to complete calls. Usually, it will take more than a few seconds, so you won't have many data points on the lower end of the range. Okay, I will give you one data table in the next thing. Let me give you with some examples. Okay, so consider a basic example below to understand histogram. The local distribution company wants to understand more about how well drivers are meeting the estimated arrival times. Okay, let's see one example so that you understand this. Okay, the drivers. Okay, and let's see whether they are coming earlier to the targeted time or this thing to the target time. Okay, I'll go to the table. Okay, so the estimated time of arrival is 8, 8:30, 8:50, 9:15, 9:45. These are all estimated arrival times. But actual arrival time is 7:55, 8:20. So the difference negative means they have arrived earlier, and the difference positive means that they arrived late. If this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super clear. So this is a data table of the arrival. Okay, now I can make the bin for the histogram. Okay, I see that the lowest is -30, the highest is, so I can draw a bin between to cover all these data ranges. -25 is there, so I taken bin from -30 to 50. I also find 48 here, so I found I can make the bin interval we call, right? Cell interval, class interval, or bin. So how many data points are there between -20 to -30? 2 data points. How many are there between 0 to -10? 3 data points. 0 to 10, 5 data points. 10 to 28 data points, 40, and so on and so forth. Okay. Now we will make a histogram out of this. You find that the range is from -27, that is, somebody is as early as 27 minutes before and as late as 48 minutes before. Okay, so we decided that 10 bin, size of 10 bins we have made, and these are all the bins and frequency. Let's see, we'll plot histogram and see what it is. Okay, the histogram looks like this. Okay, when the histogram look like this, you can interpret the histogram. Okay, what does the histogram says? The data points -27 and -25 fell into the bin which is -20 to -29, and that is 2 data points, right? Here there are 2 data points here. We are talking about here, and so on and so forth. The reason that I showed you here is whatever is the bin that you have, the class interval and the data points we've shared, we have plotted like this. Okay. Now, what I want you to understand is when dealing with histograms, the number of bins is very important. All of you type NOB in the chat box. Very, very important. Okay, this is something people don't explain. Number of bins is very, very important. As a thumb rule, there are a lot of thumb rules. One of the thumb rule I give is the square root of the sample size. Okay, square root of the sample size. If there are 100 numbers, you can square root and have 10 bins. Okay, something like that. Okay, if there are 50 samples, then 7 bins can be there. 7 sevens are 49, something like that. Okay, and there are various thumb rules for this. Okay, and softwares also use some rules to calculate this. It cannot have too few bins. It cannot have too many bins because it will show a different pattern of data. It will be very difficult to read from the data. So I will show you the graph with too many bins and too little bins, and we will see how this interpretation of the data changes. Okay. Okay, so this is with 7 bins, the same data point with 7 bins and 16 bins. Are they same or different? All of you type D if it is different. This is the same data point with 7 bins and the same data points with 16 bins. They are different. Okay. The same with 29 bins and 57 bins. How is the pattern? Same or different? Different, right? So the selection of the class interval is very, very important. Look at this. I've shown you where 5 bins are there, 24 bins are there, 43 bins are there. Okay, 62 bins are there, 81 bins are there, 100 bins are there. Okay, almost 100 data points, each and every number will become one data point. Okay, so the bin sizes, this is very important to understand. Okay, this is very important to understand. The bin sizes get progressively smaller as the number of bins increase. I don't want to explain you. You'll have to understand logically. Okay. In the first chart, bin size is 5, and the last, bin sizes are 0.5 or 1. Okay. For the purpose of understanding what the data is represented in the histogram, second or third charts are probably most relevant. So the bin which has got about square root of the number of data points is more relevant. Okay.